Hello guys, welcome to a problem in Leetcode called Fair Candy Swap. And let's read out the problem. Alice and Bob have candy bars of different sizes. AI is the size of the ith bar of candy that Alice has, and BJ the size of the jth bar of candy that Bob has. Since they are friends, they would like to exchange one candy bar so that after the exchange, they both have the same total amount of candy. Okay, so total amount of candy is the sum of the candy bars that they have. Return an integer array answer where answer of 0 is the size of the candy bar that Alice must exchange and answer 1 is the size of the candy bar that Bob must exchange. Okay, and we are guaranteed that at least one answer exists. So let's quickly see the question. See, Alice has candy bars which are of sizes 1 and 1. So Alice has a sum total of 2, amount of 2 candy bar, and Bob has 2 plus 2, 4. Total amount of his candy bar is 4. Now they can exchange one candy bar each. Since they are friends, they'll exchange so that both of them are finally left with equal number of candy bars. See, so here if Alice exchanges the one candy bar, right, then Alice has a total of two. If she exchanges one, she gives away one and she takes this two, right? So 2 minus 1 plus 2 will be the amount that Alice has. So she'll be left with 3. Similarly, Bob has 4. If Bob gives away the 2 candy bar, he'll be left with 2, and Bob takes 1 from Alice, so he will get 3. So Alice and Bob both will have 3. Similarly, in the second example also you can see Alice has a sum total of 3, Bob has a sum total of 5. So if Alice gives away her 1 and takes the 2, so she will get 4, right? And Bob has 5. If he gives the 2 amount of candy bar, Bob will be left with 3, but then he's taking 1 from Alice, so Bob will also have 4. So similarly, all the examples are there like this. So it's not necessary that it is both of them have two candy bars. So see, in the last example, Alice has a sum total of 8 and she has 3 candy bars of 1 to 5, and Bob has a sum total of 6. So if Alice gives away her candy bar which has amount 5, she'll be left with 3, and then she'll take 4 from Bob, so she will have 7. Bob has 6 now, he also has to make 7. So Bob will give away the 4 candy bar and Bob will take 5. So Bob will get a sum total of 1, right? So Bob will have 7. So basically this is the question, and it's a fairly simple problem. You can do it actually in O(n) square by brute force, right? How we can do by brute force is just if we search for elements in both a Alice array and Bob array, and then there'll be a relation between both of them. So you can see here that um, this equation will be formed. Let's say Alice has a sum total of a and she gives away the candy bar that is called x, and then she takes a candy bar of some total of y from Bob. So this will be Alice left output, and this should be equal to the output which Bob has. So Bob has a sum total of SB initially without doing anything. After exchanging, he gives away y and he takes away x. So that if we equate these two, we get this relation y equal to x plus sum 2 minus sum 1 by 2. So basically this is the equation that we can do by brute force, right? You can search for this equation, but then that will take O(n) square time, so we'll do it in O(n) time. So let's see how we can do it in O(n) time. See, what I'll do is I'll just quickly declare int sum 1 and sum 2, so that I'm going to just find a sum first of all in both of these, and then I will have to satisfy this equation, right? Y is equal to x plus sum 2 minus sum 1 by 2. This equation should definitely be satisfied, so I'll declare something called delta, right? Delta should equal to sum 2 minus sum 1 by 2. So for that I'm declaring delta. Now let's see what we can do smartly. We can iterate through the second array, through the b array. So I'll just quickly iterate through this array. And in this array, what we'll do is first we will store sum 2, right? Sum of all the elements is sum 2, that will be got by iterating through this array. And also I'll do one thing. I will store all the elements of B in set. So let me quickly declare a set. Set int s1 is how we declare a set, and I will just store all the elements of B in set. So I'm doing s1 dot insert bi. So all the elements of set are all the elements of B are getting inserted in set. Now what I'll do is I have this set which has all the unique elements of B, right? Now I can iterate through the X array in O of n times, and I can compare whether this equation is getting satisfied or not. So if this equation is getting satisfied while iterating, for whichever element this equation gets satisfied, I can just I can just know that that is my answer, and then I can just return my answer. So basically we have to return a vector int as answer. So I'll just declare a array called vector int which I'm going to return, and this array should have two elements actually. First is what Alice is exchanging, second is what Bob is exchanging. Okay, now I'll just quickly take some of the a array also, Alice array also. I am just taking some, so this should be lot of spelling errors is what I make when I try to do something fast. So actually we should do it with patience, but yeah, I can definitely work on that. So now let me show you what I was trying to say. So I'll just iterate through a array. Let's say I'm just iterating through that. Now I am iterating through this array. So for iterating, I'll just declare, you can either declare auto it, I mean that will automatically, a compiler is going to assign the iterator variable, means the type to the iterator variable. Or you can also just declare the normal, you can tell the compiler what type of variable it is. So I will give it as set int iterator. This is the type of the variable, right? It's a iterator variable, so you can use this also. And now what this iterator variable is going to do, it's just going to find if this element, right, exists in the set already. Y is an element in the set B, right? So if y exists already in the set, that means we have found the element that satisfies the equation. We just need to find elements that satisfy this equation. That is going to be our answer, right? So I'll just see s1 dot find. So x is nothing but element of a, so it will just be a of k, and plus it should be delta. Now I have not declared delta, so I'll quickly declare delta here. Delta is sum 2 minus sum 1 by 2. That is what is our delta, and I'll just give a bracket. So that's it. And if, and it's going to find it, see if it is able to find, then it will return something which is not the end of the set, right? If it is able to find, so if it is not equal to s1 dot n, that means we have found the element. We can just do answer dot push back. We have to just push back allies element. So allies element is just a of k, and then we can also just simply push back Bob's element. So Bob's element will just be a of k plus delta. That is going to be Bob's element, and then you can also return the answer. Now I'll also have to give a return answer in the end, because or else a compiler will not accept this answer. Need something to return to in the end. Error extended optimize. So I think I've just forgotten to put a bracket. So yeah, I've forgotten to put a bracket after this. Yeah, now it should work. Let's just check. So yeah, it's accepting. I'll submit and see if it passes all the test cases. In this O of n, it should pass. It should not give time limit exceeded. Yeah, it's passing. Thank you.